Alright, yo, it's Mr. V coming at you with the last final review video thing. And actually, this one's a little special because I have about 25 of my closest friends with me right here, all sitting around, and they're actually going to do the review with me. They're getting crunk. They're happy to do some algebra. Let's freaking do it. Alright, number one. Find the sum of polynomials, blah, 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 and blah, blah, blah. Wow, that's a lot of blah, blah, blah. Well, if I want to find the sum means I'm adding. I'm just adding things together. All right, well, I'm looking at this. I have 6 total things. 1, 2, 3, 4, 5, and 6. Now, they're in pairs. 1 looks a lot like number 4. So I'm adding them. I have a negative 2 and a positive 5. Negative 2 plus 5, when I combine them, I get 3x squared. Remember, I'm combining my like terms. Alright, well, number 2 and number 5 also look like each other. Number 2 and number 5, because they both have just x's. Just x's. Now, don't forget the negative that's sitting right here. I have a positive 5x and a negative x. When I combine those, I get plus 4x. And finally, I deal with the lonely old numbers at the end. My 3 and my positive 2. I combine those, and I get what?
5.
Thank you. So I have 3x squared plus 4x plus 5, so my answer choice is B. Pretty easy stuff. Number two, I was working with some of you on this in class, and you were getting real stuck. The only difference is I now have this negative that's out in front of the parentheses. When I have something out in front of the parentheses, I need to get that bad boy in, so I distribute. I distribute that negative everywhere. So this becomes a minus x squared. Negative times a negative is a positive 3x, and a minus times a positive is a negative 2. Now, I can go through and do what I was doing before. I have a like term right here. What else matches with that? Well, I'm looking for my x squared term. So I have 5x squared, negative x squared. I'm combining them, so I have 4x squared. Then I go to my x terms. I have a negative x. I go over here. Here's my x term over here. Negative x, 3x. I get plus 2x. And then finally I go to my last terms, my little numbers by themselves. So I have a positive 1 and a negative 2. I get negative 1. And hopefully you are smart enough to look at that and pick answer choice D. If you are not, I will pray for you. Oh my goodness. Number three, find the perimeter of a square. Well, how many sides does a square have? 4, ya duh. But they only label one of them, so let's go ahead and label all the other ones. If I ever see shapes without their other sides, I'm going to go ahead and label them. Alright, well, perimeter. How do I find perimeter? I add all the sides. I'm going to add all the sides. Alright, well, I'm looking at this. I have a 3x plus 1, plus a 3x plus 1, plus another 3x plus 1, plus another one. So I'm just adding them all together. If I'm counting up all my x's, I have 3x, 3x, for a grand total of 12x. Then I have 1, 4, plus 4. So my total perimeter is 12x plus 4. Answer choice C. Alright, moving right along. Number four, I want to simplify. Well, it's sort of like something we've seen before. I have something that's outside the parentheses wanting to get inside the parentheses. If I want to get it inside the parentheses, I need to distribute. Woo! So I have 2x times 3x. 2x times 3x. 2 times 3, I get 6. But don't forget those x's. I have x times x, so I get x squared, 6x squared. Now stop. The next part is where everyone messes up. They're going to look at this and say 2 times 4 plus 8. And they are going to choose answer choice. Well, it's not up here. The next one I'll show you. It's a fuller answer choice. But they're going to leave out this x right here. Remember, I have 2x times 4. I have to multiply the numbers. Then I bring the x with it. So my final answer is A, if I'm distributing. All right, number 5, which expression is equivalent to 3x parentheses 7x minus 8? Now, hopefully, by this point, you see this word equivalent, and you're like, oh, wait, my teachers have been slapping me upside the head with this word. If I see equivalent, I think equal to. If I think equal to, I think calculator. Equivalent calculator. Equivalent calculator. Those should basically be the same words in your head. So if I see this, I can plug this into y1 and all my answer choices into y2. See if they're equal, go to the table. If they are, I'm totally Gucci. But let's do the actual math of it. I distribute. I have 3x times 7x. 3 times 7, I get 21. X times x, I get x squared. Good, that's me distributing the first one. Then this is where, again, you're likely to mess up. 3 times negative 8, I get negative 24. And look, you see how this one, it gives you that answer choice. It gives you an answer choice where it leaves out the x. There should be an x right there. So do not make that mistake. So I have an x on the end, so my answer choice is D. Woo, all right. Keep going. Betty is factoring. That's a weird name. Betty. What a nerd. Betty is factoring the polynomial 3xy squared plus 27x. She knows she should first look for a greatest common factor to factor out. What is the GCF of the polynomial? All right, well, greatest common factor. Greatest common factor is the biggest thing I can pull out of there. It's the biggest thing they have in common. Well, what is the biggest number that divides into both 3 and 27? The biggest number that divides into 3 and 27 evenly is 3. Right? I cannot divide 3 by 27. If I type in my calculator, beep, boop, 3 divided by 27, I'll get some weird decimal answer, and I don't want that. So, the biggest number that divides into 3 and 27 is 3. Well, now I have to look at my variables. Looking at my variables, what do they all share? What do they have in common? Well, they have a x in common. Do they have a y in common? No, they do not have a y in common, so I can't pull that out. So my GCF is 3x. So C. All right, number 7, very similar. In the following statement, what is needed in the blank space to make the statement true? All right, well, I'm seeing this equivalent thing again. And again, equivalent, calculator. Go to your calculator, please. Por favor. Calculadora. So I want to see which one is equivalent. Oh, Mr. Feature can't speak when he's trying to speak quickly. I see that, oh, wait, they have a blank out here. Well, when they have that blank out there, it means I'm pulling out a GCF. All right, well, how did they get from 8 to 2? What number did they pull out to get from 8 to 2? Well, I'm smart, and I see, well, maybe that's a 4. 8 divided by 4 gets me 2. Let's see if it works on this one. 36 divided by 4, does that give me 9? Ding, 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 ding. All right, well, they're missing some x's in here, too. How many x's did they pull out? Only 1. You see how if I pulled out an x here, that would become x. If I pulled out an x here, it would just become a number. So they're factoring out a 4x. And luckily, I see that down here, and I'm awesome. Remember, greatest common factor. The biggest thing that they have in common. Greatest common factor. Number 8 and 9. Oh, geez, it's factoring. I really don't want to do factoring. This is no fun. But you probably should know how to factor, so we're going to go through it. Remember, my steps for factoring, if I want to factor this guy, I start off with my A, my B, and my C. My A value is 1. My B value is 10, and my C value is 9. Remember, I get them from this equation. And I can do that because it's in standard form. We're going to talk a little bit more about standard form later, but I can get all my numbers because it is in standard form. Then I take my A and my C value, I multiply them. What is 1 times 9? Duh, 9. Then I list out my factors, the things that multiply together to give 9. The things that multiply to give 9. Well, the easy one, 1 times 9. Duh. Then I have 3 times 3. Now, a lot of people will stop there. And you actually can in this problem, but some of you can't. There's some hidden factors. And in your calculator, if you're typing this in, remember you can type it 9 divided by x into your y equals. Go to your table, see all the values. But if you were to go up on the table, what is negative 1 times negative 9? Well, 1 times 9, 9. Negative times a negative is a positive. So, this is also a factor of 9. I can also have negative 3 and negative 3. Alright, so those are all my factors of 9. Now I want to find which group of factors adds up to equal my b value. Well, 1 plus 9, I get 10. Well, that was easy. I picked the first one right away. So I go to my box. In the first corner of my box always goes my first term. First box, first term, x squared. In the last box goes my last term. Last box, last term. Now, in these diagonal boxes, I take my factors that I found. So I have 1x and 9x. It does not matter if you put the 9x here and the 1x over here. You'll get the same answer. Alright, what do these two boxes have in common? They have an x. Alright, well now I can do my what times what times what equals what? X times what gets x squared? X. X times what gets 9x. And then I have x times what gets 1x. 1. You can play that game all the way through and you will get your factors. And remember, my factors are the things that are on the outside. So my factors when I'm all done are x plus 9 and x plus 1. These are my factors. Now, I went through a pretty long problem really fast. If you didn't get it, stop the video, rewatch it, and see where you messed up. Or, better yet, try the next one on your own. Go back and use number 8 as like a skeleton for actually doing it. Use number 8 as an example. Try number 9. Number 9, I'm actually going to take a different approach with you. Number 9, I have the beginning, and I have all these factors. If I want to see if these factors are this, right, because these things are what I started with, just represented in a different way, I can use my calculator. Why not plug this into y1 and all my answer choices into y2? I can see which one is equal to my beginning stuff. I can just start off by plugging this into y1, y2, going from there. And when you get that, let Mr. Vincher do some fancy math in his head, you should get D. D is the final answer. So I'm not going to factor that one for you. If you want to, you can try it on your own, or you can plug them into your y1 and y2. Next page. Oh, there's a little bell here. That's going to be the next page bell. Also, fidget spinner break. Woo! Number 10, number 10, number 10, and 11, and number 12 are all asking us the same thing. That was Danny just making a noise, and I gave him a death glare because I told him he needed to be silent, but he wasn't. Bad Danny. Don't be like Danny. Don't be a Danny. Number 10. Number 10, 11, and 12, I'm looking to see if there are special cases. Our special cases, remember, are difference of two squares and perfect square trinomials. Those are two special cases. All right, number 10. Is that a difference of two squares? Well, I do have two things. I do have two terms. Is it a difference? Do I have a difference there? No, it's not. It is not a difference. So it's not a difference of two squares. Now let's see if it's a perfect square trinomial. Is it a perfect square trinomial? Do I have three terms? Well, I only have two terms. So no way it can be a perfect square trinomial. So it has to be neither. Remember, dots has two terms, and I'm subtracting. It's a difference. And PSD has three terms, and the middle term has something special that I'll go over in just a minute. Number 11. Again, let's try dots. Are there two terms? Are there two terms in this? Yes, there are two terms. Is it a difference? Yep, I have subtraction in the middle. Well, now let's see. Let's see if I can take the square root of the first term and square root of the last term. Square root of x squared is x. Square root of 16 is 4. So this is, in fact, a difference of two squares. Now, when it was neither, I couldn't factor it. Here I can factor this pretty easily. I always start by just putting my open parentheses. Then, what times what got me x squared? Well, x. So I put an x and an x, and then I have what times what got me 16. So I have 4 and 4. Now for difference of two squares, on my factors, one's going to be positive and one's going to be negative. So I have a positive and a negative for difference of two squares. Number 12, finally, we're almost done with this section. Is it difference of two squares? Well, 2, do I have two terms? No way, Jose. No two terms. No. So it is not difference of two squares. I actually have 3 terms. Perfect square trinomial. Trinomial stands for 3 terms. So do I have 3 terms? Yep. Let's see. Can I take the square root of the first term? X. Yep. Can I take the square root of the last term? 5. Now, this is the weird rule I was talking about earlier. I have to take this thing and multiply them by 2. When I do 2 times x times 5, what do I get? Well, I get 2 times x, 2x, times 5, 10x. Is that what I have in the middle? Yes, I do. Therefore, it is a perfect square trinomial. I have to do the square root of the first, square root of the last, multiply them together in 2. If I get the middle term, it is in fact a perfect square trinomial. Alright, well now this one's a little bit easier to factor. Again, I'm going to start with my open parentheses. What times what got me x squared? X. So I put an x and an x. What times what got me 25? 5. So I put a 5 and a 5. In a perfect square trinomial, the signs are going to be the same. And how do I know what that sign is going to be? Well, I look at the 10. I look at the middle term. If that's a positive, therefore these will be positive as well. Now, everything I just talked about is on your formula sheet. All the formulas for difference of two squares and perfect square trinomials, again, they're all on the top of your formula sheet. So, if you forget, go look at that, but at least familiarize yourself with all what's going on. Alright, number 13. Number 13, if the area of a rectangle is blah, 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 which of the following represents its dimensions? Remember, dimensions are the things that I multiply to get area. Well, again, there's a really easy way to do this problem. I have this, and I have all these answer choices. Why not plug this into y1 and my answer choices into y2? And I can see which one comes out to be equal. I'm going to do this one an even different way. So there's tons of ways you can solve these problems. I'm going to do something called FOIL. And you learned FOIL. Some of you just aren't using it. It's an acronym for us to multiply things. F in FOIL stands for first. I multiply the first things. I'm actually going to do it on, let's do it on C because I'm smart. I'm going to do the first times the first. X times x, I get x squared. And then O stands for outside. So the outside term and the outside term. So x times 3. And I get 3x. Then I have I, which stands for inside term. So the inside and the inside, I have 2 times x plus 2x. And then I have last terms. So the last term and the last term, 2 times 3, and I get 6. Now all I need to do is combine my like terms. And my like terms are the ones that are in the middle. So I have x squared. Then I have a 3x and a 2x to get 5x. And I have a plus 6. Is that what I started with? Yep. So I know that my answer choice is C. Now you see why Mr. Vinstra started with C, partially because he's a genius. Number 14. Number 14, I need to divide the polynomial by factoring. Divide the polynomial by factoring. Alright, well I'm looking at this top part right here. A lot of you will try and divide this and this. You'll go, oh, 8x divided by 4x, I get 2x. And then 4 divided by 2, I get 2. If you just did that, stop. Slap yourself and walk out of the room, splash cold water on your face. Then come back in and try and actually be smart and do some math. Because you cannot do it this way. What you have to do is you have to pull out a GCF. You have to pull out a GCF. So let's look at the top first. Just the top. What divides evenly into 8 and 4? A 4. A 4 divides into 8 2 times. And a 4 divides into 4 1 time. Now let's go to the bottom. I have 4x and 2. What divides into those? Well, a 2 goes into 4 and 2 evenly. That's the biggest thing. It's the greatest common factor, the thing they have in common. So I divide 4 by 2 and I get 2x. And then I divide 2 by 2 and I get 1. Now you see something special, right? I have a 2x plus 1 and a 2x plus 1 on bottom. Jose, you're smiling and shaking your head. He was. I totally got him. Jose, if I have a 2x plus 1 and a 2x plus 1 on top and bottom, what can I do, sir? Oh, he's choking under pressure. He's choking under pressure. Oh, I think I heard him say you can cancel them out. Good job, Jose. You can cancel them out if I have something on top and on bottom. Now, I have 4 divided by 2. 4 divided by 2, I get 2. Therefore, my answer choice is C. Number 15. Wow, number 15 is a long problem. And I've talked to a couple of you about this. I want you to solve this using your calculator. Again, if you see something equivalent, calculator, please don't break Mr. V's heart by using non-calculator on calculator problems. They're so easy. You could get so many points. Just do it, please. Please. So, if you were to type this in the calculator, you need to do all of this, so put it in parentheses, divided by all of this, again, parentheses, into your y1. And then you type all of this, parentheses, divided by all of this into your y2. Or this into y2. Or this into y2. Or even this into y2. See which one matches up. If it matches up, ding, ding, ding. Winner, winner, chicken dinner. You've got your answer. Mr. Vinstra is going to be ruthless and not going to give it to you. You have to do that one on your own. So pause! Okay, welcome back. It's after the pause. We're going on to a new section. We want a new color. All right, class, you get to vote on this. I've been using blue. Raise your hand if you want red.
Yellow.
Oh, you suck. Raise your hand if you want green. Raise your hand if you want blue.
Orange. I want green.
Oh, okay, we got green.
Orange.
Oh, yeah, raise your hand if you want orange.
Oh, I want orange.
Oh, okay, Oswaldo wants orange, so we're not going to give him orange. Hey. I didn't mean you guys were stupid, by the way. You guys are not stupid, because you're watching this video. If you're watching this video, clearly you're smart. Alright, quadratic equations unit. Quadratic equations unit. Well, quadratic equations, remember those are my parabolas. Parabolas. Parabolas are my U-shapes. Just like we see on my graph over here to the right. Alright, so 16 through 19 all use this information over here. And there's actually an error in here one place. 16, f of x equals x squared plus 6x plus 10. When f of x is equal to 2, I want to find x. Remember, when it says f of x is equal, that's like saying y is equal to 2. Y is equal to 2. So I'm going to go ahead and draw a line where y is equal to 2. Remember, y equals lines are horizontal lines going straight across. So, my x values, when y is equal to 2, is at -4 and at -2. So I have two answer choices, A and C. So when y is equal to negative, or y is equal to positive 2, touches my parabola twice. That means I have two solutions. They are A and C. Number 17 is actually the one with the error. I have f of x is equal to all this stuff, which is my graph over here. And I have f parentheses -3. Remember, when it's on the inside of the parentheses, that's telling me my x value. Outside the parentheses, y value. Inside, x value. So I'm going to draw a line. I'm going to use a different color. For my x is equal to -3. Well, here's x is equal to -3 right here. So where does this line touch the parabola? Right here, which is at y equals 1. So my value is 1. I don't actually see that on my answer choice. That's where the error is. There's no choice for y equals 1. Well, that line that I just drew, just to go off on a tangent, that line I just drew, something special about that line. And I see it goes straight through the parabola. It splits the parabola in half. We have a special name for that line, remember, and it's called the axis of symmetry. The line that goes directly through the parabola, and it goes through whatever point this is called down here, which is the vertex. The axis of symmetry goes straight through the parabola, and it goes through the vertex. Alright, number 18 and 19 are very similar. I have 1 is equal to x squared plus 6x plus 10. Well, again, I just replaced the f of x with a number. So I have the line y equals 1. I'm getting sort of crowded over here, I apologize. But if I were to look at this and I have y is equal to 1, that would be this line right here. Y is equal to 1 is this line right here. Again, if you're not paying attention, you might not know where that line is. It's right here that I'm tracing it. Y is equal to 1 because the y value is 1. Alright, how many times does this touch the parabola? Well, it only touches once. And it touches at -3. -3. So my answer choice is -3. B. And finally, my last one. I have the line 0, because I replaced the y value with 0. So I go to where y is equal to 0. I draw a line across. Y is equal to 0. How many times does this parabola right here touch the line y equals 0? Well, it never touches, right? And if it never touches, do I have any solutions? No solution. So my answer choice is E. Alright, we're making good time on this. Number 20, I'm using the quadratic. Oh, hello, pencil sharpener. Number 20, given the quadratic equation 2x squared minus x is equal to 7, which of the following is set up correctly to use quadratic formula? Now, again, this is another place where I promise you're going to see it on your final. I promise you're going to see it on your final. And I promise you're probably going to mess something up like this. To use quadratic formula, I need to be in a certain form. That form is called standard form. I have to be in standard form before I can use the quadratic formula. Now, standard form is always equal to 0. This one is not equal to 0 right now. It is equal to 7. And I need to get it not equal to 7. So to get this 7 on the opposite side, I need to subtract 7, and I subtract 7 on the opposite side. Now, I cannot combine like terms with anything over here, right? Because there are no other numbers over here. So I'm just going to rewrite it. I have 2x squared minus x minus 7 is equal to 0. Now I am in standard form. Ding, 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 ding. Also, I just gained a new fidget spinner because someone was playing with it. It's mine. I'm going to have a collection. So my A is 2. My B, well, there's no number there, but remember there's a imaginary 1. Don't forget the negative. It's equal to -1. C is equal to -7. Alright, well now I can use all of that to plug it into that big long formula we learned. Oh, you probably should be able to see. That'd be helpful. Remember, I have x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. Mr. Vincho learned a really funny song to remember that. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all divided by 2a. And that's how Mr. Vincho memorized that equation. So I can plug in all my numbers. I know I'm going to get a negative 1 because it is a negative in the equation and I have a negative as my b value, plus or minus the square root of b squared, so -1 squared, minus 4 times, I'm getting real tiny over here, 2 times -7 Make sure you're listening to what I'm writing, not just copying. Divided by 2 times 2. Alright, well, I'm looking at this bottom part over here. I have a 2 and a 7 at the end. Well, C and D don't have it. They have a positive 7. Positive 7, so I know they're out. Now I'm looking at, actually A has a positive 7 as well, so I can cancel that one out and automatically know it's B. I'm a genius. I rock. Next page. We're almost there. Alrighty. The next section, I have a bunch of these graphs, and I want to know, hey, you should probably be able to see it again. I have a bunch of these graphs, and I want to know different things about them. I want to write the letter. Oh, yeah, I need the bell. Next page, Bill. Thanks, Danny. Appreciate you. You can have your fidget spinner back.
I appreciate it.
Oh, yeah. See what happens? You do nice things and remind teachers, you get rewards. Write the letter of the graph for each statement for which is true. You may use the graphs more than once. All right, number 21. The function has exactly 1 0. Well, first of all, we need to know what the word 0 means. Remember, 0 is x-intercepts. X-intercepts. So, which one only has 1 x-intercept? Well, this one has 1, 2. That one's out. Does this one have any x-intercepts? No. This one, bing, 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 only has 1. This one has 1, 2. So the only one that has 1 is C. Number 22, functions has exactly 1 solution at y equals negative 2. Well, this is sort of like we were doing earlier. If I have the y equals negative 2 line, it's this line right here. Y equals negative 2, y equals negative 2, y equals negative 2, and y equals negative 2. And remember, if there's only 1 solution, it only touches once. How many times does D touch? It touches once and twice. The parabola touches the line I just drew, y equals negative 2, once and twice. So that one's out. C doesn't even touch it. Wow, you're lame, C. And then A touches once, B touches once. So I have A and B. Number 23, which one has 2 roots? Well, again, there's another word for roots. Roots is just another way of saying x-intercepts. Another way of saying x-intercepts. So, which one has 2 x-intercepts? I have 1, 2. A, you're so good. B has, you suck, B. You're out. C has, C we already figured out has 1. D has 1 and 2. So, my answer choices are A and D. Okay, number 24. Which function or functions has no solution at y equals 0? Well, again, I need to draw in my y equals 0 line. My y equals 0 line, remember, is flat right here. Right here, right here, and another one. So which one has no solutions? The only one that has no solutions is B, because it never touches. Number 25, the zeros of the function are both positive. Now, this one can be a little bit tricky, right? Zeros. What are zeros again? They are my x-intercepts. X-intercepts, and I want them to both be positive. Well, I have this one, A, right here. It has 2 x-intercepts. This one is clearly positive. Now, the other one is kind of tricky. The other one is right at 0. And 0 is weird because it's not positive and it's not negative. It's neither of them. It's just 0. It's neither positive nor negative. So, this one is not positive. This one doesn't even have any, so we don't have to worry about him. This one has 1, and it is negative because it's sitting at a negative x value. Now, this one over here has 1. Good, it's positive. 2, it's positive. Ding, ding, ding. So when you're looking for positive roots, you want to look for the right-hand side of the graph, where the x is positive. All right, we're making good time. Number 26. What are the roots of the equation? The roots of the equation. Well, remember, roots are another word for x-intercepts. And x-intercepts happen where my y is equal to 0. Kind of confusing, but remember, I'm looking for where my y is equal to 0 for my roots or my x-intercepts. So where's y equal to 0 in this graph? Well, I go down to my y. I have 1 right here at negative 2. And I have another place where it is 5 and 0. Now, I'm not looking for where x is equal to 0. No, 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 no. No, no, no. No. Bad. No x is 0. Only y is equal to 0 when I'm looking for x-intercepts. So now I have negative 2 and positive 5. So my answer choice is 1 and 3. Answer choice B. Alright, number 27. Very similar, but what are the answer choices? What are the solutions when f of x is equal to negative 12? When f of x is equal to negative 12. Well, remember, f of x is just a fancy way of saying y is equal to negative 12. So where's y equal to negative 12? Oh, right here. And it's negative 1. So I'm done. Yay! No. I'm not done. I'm not done. And I bet you, again, Mr. Vensha's helpful hints, I bet you will make this mistake. Look everywhere. Look all over the table, because there is another one in here at 4. Usually in parabolas, values repeat themselves. So I have one solution right here at negative 12 and another solution right here at negative 12. So my answer choices are negative 4 and positive 4. So it is 2 and 3. My answer choice is again B. All right, number 28. We already sort of talked about this. Which one of the following quadratic equations is in standard form? Remember, standard form is equal to 0. Standard form is always equal to 0. Well, what's the only equation in here that is equal to 0? Well, that is answer choice D. Number 29. Wow, we're getting so far ahead. Number 29, given the following quadratic formula, determine the quadratic equation in its standard form. Alright, well, we just have to work backwards. Remember, I have x is equal to negative b plus or minus the square root of b squared. So b squared minus 4ac all divided by 2 times a. Alright, well, right off the bat, I can find my a and my c. My a is going to be 4. And my c is going to be 6. So now I'm going to have 4x squared plus something b plus 6 is equal to 0. Let's see if we can eliminate any answer choices. Well, I can get rid of d because it is a negative 4. I wanted a positive 4. I can get rid of a and b because they have 3s, and I didn't want those. So already I've eliminated all the ones, and I know my answer choice is C. If I wanted to, I could see that my b value is negative 3, so this is actually going to be minus 3x in the middle. And that's what they got on the one we got. Killing it. Number 30 through 35, I am matching. It's so easy. I am just matching. I want to find the best way to solve each problem. The best way to solve each problem. Alright, well, these are all my methods for solving quadratic equations. Let's use dots and PST first, because those are the ones we've already talked about. Remember, dots is difference of two squares. Difference of two squares. Do you see anyone on there that is difference and has two parts? Well, I only see one of them, and it's number 33. Number 33 is the only one that has two parts and is subtraction in the middle. So I'm going to say that this one is B. Okay, now let's look for our perfect square trinomial. Remember, it's going to have three terms, and I'm going to have to be able to take the square root of the first term and the square root of the last term. Well, I see that I have 2, can't take the square root of that, can't take the square root of 3. I can take the square root of this, but it has only 2 terms. I already used this one. This I could take the square root of, but this is in standard form. Let's not worry about it. Let's look at 35. Can I take the square root of x squared? Yes. It is x. Can I take the square root of 25? Yes. 5. What is 2 times x times 5? I get 10x. Is that what I had in the middle? Bing, bing, bing. This is my perfect square trinomial. My perfect square trinomial. I'm sorry, Mr. Vensha's being real bad about moving his paper up. I'll move it up so you can see exactly what I did and give you a couple seconds. Alright, the next easiest method, in my opinion, would be square root method. Square root method. Remember, I have to have perfect squares for square root method. I have to be able to take the square root and the square root. Well, I automatically see it, and I see it's number 32. And I see it's number 32 because I can take the square root of x squared and the square root of 49, and I get 7. So this one is going to be my square root method. Now, the next easiest one in my mind is completing the square. The thing you need to know for completing the square is the b term needs to be even. The b term needs to be even. Alright, well, I'm looking at these, and I see that this one, 30, already has a term over here, so I know I'm not going to add something to this side. This one is even in the middle, so I can add things to both sides. So this one is going to be completing the square. And then finally, my factoring and my quadratic formula. Factoring, I just have to be able to do the actual factoring. So this one, I'm going to look at number 31. My a is 3, my b is negative 2. So I have 3 times negative 2, negative 6. Are there a factor of negative 6, or is there a factor of negative 6 that adds up to equal 5, my middle term? There is. 6 and negative 1. 6 times negative 1 gets negative 6. 6 plus negative 1 gets me 5. Voice crack. So this one I know I can factor, and the bottom one, the top one actually, I know I can do quadratic formula. I would always save quadratic formula for last because you always know quadratic formula can solve it. Alright kids, that is half of the review. Half of the review that Mr. Veenstra just straight up gave you. Again, if you want to go back and study just to make sure that you're going to be super prepared for the final, go back, rewatch the video. You totally can. It's totally up to you. But I promise you, if you do the video and you watch it multiple times, you will do well on the final. Alright, this is Mr. V signing out with a fidget spinner. See ya! The pause, the stop button. What?